Lesson 5 of Chapter 1 of Geometry. Our topic today is exploring angle pairs. So our objective for today is to identify special angle pairs and use their relationships to find angle measures. So we look at this game board over here. We've got 5 game pieces that form a square if you fit them back in the box correctly. And so 2 of the shapes are already in the place where they need to go. You have to try and determine where the other shapes go. So make a sketch of the completed puzzle. Pause the video here and check to see if your sketch agrees. If you look at my sketch, you can see where I fit those other 3 shapes in there. And being able to fit those shapes in there, you start to understand about angle relationships and, well, how these things are all going to fit together, what angles are complementary, what angles are supplementary, and where they're all going to fit. And that's a lot of what we're talking about today. So, essential understanding for the day is that special angle pairs can help you identify geometric relationships. You can use these angle pairs to find measurements. So here are the angle pairs we're going to be talking about today. We're going to talk about adjacent angles. And adjacent angles are 2 coplanar angles. That means they're in the same plane with a common side and a common vertex. So if we look at these, angle 1 and angle 2 share this common side right there, and they have a common vertex right here. Angle 3 and angle 4 share a common side and a common vertex. The next one we're talking about is vertical angles. Now, vertical angles are angles, 2 angles whose sides are opposite rays. And so if we look at these for angle 1 and 2, well, here's one ray making up angle 1. Its opposite ray is over here making up angle 2. And the same thing can be said for the other sides of those 2 angles. And it's the same thing with angle 3 and angle 4. And so then our next topic are complementary angles. Complementary angles are 2 angles whose measure have a sum of 90. Each angle is called the complement of one another. And it's a different type of complement than, oh, I like your hair, or I like your shoes today. These are angles that add up to 90 degrees. And so if we look at these, angle 1 and angle 2, it's got this little red box written in there. And if you remember, we said that box equals 90 degrees. And so that tells you that angle 1 and angle 2 together are 90 degrees. You can also do a problem like this one over here with A and B. They gave you the 2 angle measures. If you add up those 2 numbers, you're going to get 90 degrees. And so you know those 2 are complementary. Our last angle pair type we're talking about today are supplementary angles, and these are 2 angles whose measures have a sum of 180. Each angle is called the supplement of the other. And so if we look at our diagram, a line that is 180 degrees is a straight line, and so if you see that these 2 opposite rays making up angle 3 and angle 4 is a straight line, and so then angle 3 and angle 4 must be 180 degrees when combined. If you look at the next one, this one goes up to angle B up above and angle C down here. These 2 together are going to add up to 180 degrees, and so they are complementary as well. Alright, so here we have some statements. We're going to use the diagram to the right to decide if these statements are true or not. So we have angle BFD, that's right here, and we have angle CFD. That's going to be right here. And we need to decide if these 2 are adjacent angles. Well, first off, do they share a common vertex? Yep, right here. Second off, do they share a common side? They do, but it's down here. And so because they share this common space in here, they are not adjacent angles. They would have to not have a common interior that they're sharing. So we would say no. Our next one is angle AFB and angle EFD. So angle AFB is right here. Angle EFD is down here. We need to decide if these are vertical angles. Well, remember, vertical angles are made up of opposite rays. And so if we look at these, opposite rays make a straight line. And so angle B, so that would mean that this ray FB and this ray FE would have to make a straight line, and because they don't, we know that no, these 2 are not vertical angles. Our next statement says that angle AFE and angle BFC are complementary, so AFE and angle BFC. Now remember, complementary angles means they're their sum is 90 degrees. So we go 62 plus 28. Well, that equals 90. So yes, these ones would be complementary. So what I'd like you to do now is there's a diagram with many different angles, and I'd like you to answer A, B, and C and decide if they are true. So pause the video here and take the time to answer those 3 questions. Answers for each one of these questions. Angle 1 are AFE and CFD vertical angles. They are, because as you can see that this AF and FD are opposite rays, and then this EF and FC are opposite rays. Alright. For 2 are BFC and DFE supplementary. Well, if you look at them, measure angle BFC is 28 degrees, and the measure of angle DFE is 118. If we add those together, we do not get 180. And for C, our BFD and AFB adjacent angles, well, if we trace those, we have BFD and we have angle AFB. They share a common vertex and this common side, so they are adjacent angles. Alright, and so now we have just kind of a summary of these concepts. There are some relationships that you can assume to be true when you see a diagram. You can assume that angles are adjacent. So these are all things that, yes, you can assume. Angles are adjacent and supplementary, and angles are vertical angles. So those are things when we see a picture, you can just automatically assume those. Now, there are things that you cannot assume and you cannot conclude about your graph, and these are these 3 statements down here. Whether angles or segments are congruent, whether an angle is a right angle, and whether angles are complementary. So we cannot conclude these things unless there are extra drawings in our picture. And so here we've got this diagram. And so what are some things we can assume from this diagram? Well, we can say that angle 3 and 4 are adjacent, and they're also supplementary. So they're adjacent and supplementary, and I always abbreviate those. We can say that angle 5 and angle 4 are adjacent and supplementary as well. We can, thanks to the notation that they gave us in the drawing right here, we can say that the measure of angle 1 is the same as the measure of angle 2. We can say that angle 3 and angle 5 are vertical angles. If you look at those rays, that's true. And so these are some things that we can say about these angles. So what I'd like you to do now is try and answer these 4 questions using this diagram below. You can, I'd like you to pause the video and take the time to answer these questions. And so here are the answers, my answers to the questions. A, line segment TW congruent to line segment WV. They have these markings, so we can say that. B are segment PW and WQ congruent. They may look like it, but we cannot say that from this drawing. C is TWQ a right angle. Well, that's one of the things that we cannot just assume without further information. So no, we can't say that. And D, does TV bisect PQ? We cannot say that. We can say that PQ bisects TV, but we can't say that TV bisects PQ because we don't know how long PW and WQ are. So those are the different things we can get from that. And so a linear pair, that's the next thing we're going to be talking about, is a pair of adjacent angles whose non-common sides are opposite rays. Alright? So the angles of a linear pair form a straight line. And so that's when you have 2 adjacent angles and their non-common sides are opposite rays. So here we have a ray. Here's our point. Here's our first angle. And then our other ray is the opposite of that first one, so it goes this way. And so these 2 angles would form a linear pair because they have this line right here where we have 2 opposite rays. So the sum of these 2 linear pairs is our next postulate. So linear pair postulate, this tells us that since they form that those opposite rays, then the two angles from a linear pair must be supplementary. And so with that information, we can then actually solve some problems, some algebraic problems. It says we have two angles, angle KPL and JPL, and I'm going to take the time to draw these. All right, we have, okay, here we have K, and P is our vertex. We're going to have L up here, and J is going to be over here. And I got all of these placements for all of these points from most statements they gave us. I know that PL had to be this common side that they're sharing, and then I knew that P had to be that vertex. So we know that the measure of angle KPL is 2x plus 24, and the measure of angle JPL is 46 plus 36. And because they're a linear pair, I know they're supplementary, which means that they must add up to 180 degrees. So I can say that 180 degrees equals the measure of angle KPL plus the measure of angle JPL. So I can plug in those algebraic statements, 2x plus 24 plus 4x plus 36. I can combine my like terms and I solve for my variable. So I get 180 equals 6x, and 24 plus 36 should give me 60. Subtract by that 60 from both sides. I get 6x equals 120, which then tells me that x equals 20. I can then use that to go back in and solve. So I have 2 times 20 plus 24 for KPL. That's the same as 64. And then I have 4 times 20 plus 36. It's going to give me 80 plus 36, which is 116. And if I check my work, 64 plus 116 is 180. So the measure of angle KPL is 64 degrees, and the measure of angle JPL is 116 degrees. So what you're going to do now is you're actually going to do a problem very similar to that on your own. You're going to have to think about this problem a little bit, though, as you do it. The first thing it asks is how can you check your results in problem 3, and then find the measure of these angles. So pause the video now and take the time to do that. And now you can check your work with mine. I got for my answer the measure of angle ADB is 77 degrees, and the measure of angle BDC is 103 degrees. So here we are onto our last slide. The next thing we need to talk about are angle bisectors. We've talked about segment bisectors. Now we're talking about angle bisectors. And an angle bisector is a ray or segment that divides an angle into two congruent angles. So it's the same type of concept. It is referred to, its endpoint is at the angle vertex. So if we're looking at this diagram below, it says in the diagram AY is the angle bisector of angle XAZ, which means that angle XAY is congruent to angle YAZ. Alright, and so now let's do a problem doing that. We have an angle DAB, and so I'm going to draw that out. Here's DAB. An angle ray AC bisects, so here's C. If the measure of angle DAC is 58 degrees, what is the measure of angle DAB? So angle DAB is the big angle, alright? And so if DAC is half of that, and that is 58, well that must mean that CAB is also 58 degrees. And if I add those two together, 58 plus 58, that'll give me the whole angle, and that gives me 116, so it must be D. So pause the video now, answer this problem number 4. You can check your work with me when you're done. So I got, from my picture, I drew it all out. Angle JKL is the whole angle, and that was 72 degrees, and they just want to know angle JKM. Half of that is, so I did 72 divided by 2, and I got that the measure of angle JKM equals 36 degrees. So this is the end of lesson 5 of chapter 1 of geometry.